بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so welcome to lecture 4 of chapter 2 Python for Data Science. It's part of the course CS316 Introduction to AI and Data Science. And today we're going to have a very important lecture. It's a topic that is a little bit under-investigated in programming courses, which is about functional programming. And to introduce you effectively to functional programming, I need to introduce a few concepts related to functions. Like, for example, first-class objects and what is its meaning, higher order functions. Have you heard about higher order functions before? Yeah, iterable. I think iterable, you should know about them in Java, like iterators. You already did iterators in data structure. Lambda expression. I introduced this lambda expression in the previous lecture when we were doing some coding. But today I'm going to give you the concepts of lambda expression and how it relates to the concepts of functional programming, and also application of functional programming and lambda expression on function programming tools like filter, map, and reduce. So this will be the overview of today's lecture. So first of all, what is functional programming? It is just a way of writing software programs that will treat computations as evaluation of mathematical functions. And this is the example, like lambda expression is one of the examples. And also, data is immutable. It means that the functions or the software will not try to change the data, but create a copy of the data after being modified. And this has some benefits. To make the original data safe, it means unchanged. So any change for the data, it requires to create a new copy of that data. This is one of the concepts that we try to follow in software engineering, okay, for the safety of data handling, the concept of data immutability. And it also provides easy-to-use tools like map, filter, and reduce, which we are going to introduce at the end of this lecture. And you can see a simple example here where we apply the concept of lambda expression, which is part of functional programming, okay, where we can call a function as argument. So usually you call a variable as arguments, like of type int or objects. This is what you used to do, but you are not used to, for example, call a function as an argument. So as an argument of another function. This is one of the concepts of functional programming that we are going to introduce today. That's also another example. Map is another function also that performs operations of particular mathematical function on a certain data structure, like, for example, list or a dictionary. Okay, so the objective of today is to introduce these concepts, okay, and how they relate to lambda expression and also the functional programming tools. So one of the functional programming techniques that you already know is what we call recursion, okay? Recursion is one of these techniques because recursion basically, you try not to change the data internally, but it will call a function inside a function in a certain way, okay, and then it will return the transformation of the data, which will be the result of obtained by that function. Yeah.
Can we do a recursion function with mutable or non-mutable data?
Yes. So yes, it doesn't matter. Yes. So the data immutability, this is an example here, okay, where we don't change the data that we provide as a parameter or as argument. So here we have data, which could be, for example, a list, and I want to add an element into that list. So the concept of data is immutable is because we're not going to change the data, but we're going to return another copy of the data. So here, if I create a tuple, or if I create a list, it could be a list. And you know that a tuple is immutable. You cannot add elements. So if you want to add an element in the tuple, you should create a new data which contains the tuple, the old data, the original data that is unchanged, immutable, plus the new element, for example, 4. And if we print the results, so we're going to have the output of the original data will remain the same. It's not changed. Okay, and the new data will incorporate the new element. Okay, so the concept of data being immutable in functions, it has benefits not to compromise the original data, okay? And this is one of the safe operations that we do for data handling. Okay, this is another example. Okay, if we want to create a list of exponents, okay, or we want to double the values of a particular list. So here you're going to return a new list without having to change the data. And you can see now the difference. Printing the original list is not changed, and after processing the data with that function, so we're going to have a new copy of the new values. Yes.
Doctor, I want to talk about this example number one.
Yeah.
About return data plus element. Why is the element in this shape?
This is the way on how we do it with tuples, because you're going to add a new element into the tuple. This is the syntax in Python. Okay. Okay, so functional programming is very important in data science, especially if you use later on neural network and advanced AI operations. So we have pretty much recourse to functional programming, and this is why it is really very important to understand it, how to use it in Python. So later on, if you have instruction like this, you have the ability to understand these concepts and how they are used. Okay, so again, the definition to functional programming, it treats computation as the evaluation of mathematical function. So this mathematical function is going to return values and can be treated also as an argument of mathematical function. And there are core benefits, as I already mentioned. Data is immutable, and also it leverages the use of high order function, which is a function that can be used as an argument of another function, or also we can use it as a variable that stores other function. I'm going to provide clear examples about this. So the key concept that we need to understand before diving deeper into functional programming is the concept of first-class functions or first-class objects, higher order functions, and pure functions. Of course, pure function, this is the normal function that you already know in most of the cases. So I'm going first to introduce or remind about the concept of pure functions. It's just a function that will take input, and the output will be a transformation of that input. You know, if you take a function multiply a and b, is going to transform into a multiplication. And the characteristic of pure function, it always returns the same result, given the same input. If you provide the same input, it's going to always provide the same result. Does not modify, and also doesn't modify any external state. It doesn't have access, or it doesn't make access to any global variable. All the variables are defined in the input or internally into the function. This is the characteristic of a pure function in Python. Okay, so it's predictable, it's reusable. You can use it as a component in different parts of your program. And concurrency, it's safe to use concurrent programming because you don't have state. Sometimes, you know, when you're going to, I don't know if you have already taken operating system, sometimes you need to make parallel threads work in parallel. Yes. So using these pure functions in parallel thread, it's kind of safe, okay, because they don't have access to shared memory. Okay, if you have access to shared memory, in this case, you need to make mutex, so you have exclusive access to a variable, okay, over another function. Okay, so high order function now, what's the definition? They are functions that can take other functions as arguments. So how is that? Now imagine that you define a function called double number. This is a pure function. Okay, it takes an integer or it takes a float as an input and will return an output. So this is basically a simple pure function. And let's look at the function process list. You have a list and you want to process it. So here we will put in the argument, the first argument will be a function and the second argument will be a list. And then I'm going to create a new list that will do what? Will apply the function to each element of the list. For example, this element will do what? It will double the value. So what will be the result if I apply double number into process list? If I take a list of 1, 2, 3, 4, 5 and applying this function as an argument is going to return a list that contains the double of all values. And this is very flexible. So flexibility is one of the features. Why? Imagine that you want to process the list differently. You want to divide by a certain number. Okay, for example, I want to calculate the exponent, not just doubling. For example, I want to calculate the exponent. Here, I can define another function, for example, exponent of a number. If I apply it here, so the behavior of processing the list will change. Okay, so it's reusable, and most importantly, it's flexible. You can apply different type of transformations by providing a different input function in the argument of the process list function. And this is the concept of high order. It's not pure because it can take an argument, it can take a function as argument, and then all it will just apply this function, apply to this list. Okay? So high order functions are powerful features in Python that allow to write expressive and concise code, so we can reduce the size of the code by reusing this function, and also exemplify a key aspect in functional programming by enabling a function to operate on another function. And you know, just this picture illustrates what is a high order function. It's a function that can take an input, okay, as basic type, or it can take an input as a function. It can return a simple output, or also it can return a function. So a function can take a function as an input argument, and it can return a function as an output of another function. This is the concept of high order functions in Python. But why is this possible? This is possible because functions are considered as first-class objects, like first-class citizens in a society. So what does it mean, a first-class object? It's an object that can be passed as arguments, that can be returned from functions, that can be assigned to variables, and can be stored in data structure. So basically, the basic types that you know, int, float, string, Boolean, are considered as first-class objects because they are able to undergo all these different types of operation. I can pass an int as an argument. I can return an int as a value of a function, right? I can assign it to a variable. I can assign int to a variable. I can store int into a data structure. I can make a list of int. I can make a list of float or double numbers. So all of these are considered first-class objects. And also functions in Python are considered as first-class objects. So I can do in Python all these operations on functions, like you do them on simple data types, like integers, strings, floats, Boolean, and others, and other even objects that you can create yourself by defining classes. Okay? So this is why it's possible to define high-order functions, and later on we will see functional programming or Lambda expressions, just an application of these concepts. Okay, but of course with a different, more shorter code to express these functions. Yes, any question?
How can functions be assigned to values?
You can make x equal to a certain function, like I think we've done here. Okay, say hello equal greet, and greet is a function. So when you say hello Alice, it's gonna call this function.
This has to be equal return.
Yeah, this is equality, a function assigned to a variable. So this variable becomes a function of type function.
The value of the function also.
Yes.
Doctor, why don't you do say hello and then Alice? Sorry, greet Alice.
It's possible. I mean, this is possible. Doesn't mean it's the best way. But when I will show you other. So I can make an assignment of a variable to a list of functions.
Yes.
And then I can call it by its index or by its key. Okay? It's a possibility. Now, whenever it's efficient to use it in your code, you will use it. But now you know that it exists. Okay? We are just showing the existence, the possibility of doing that in Python.
But this makes it first class.
It makes it first-class object.
Yeah.
Yeah, yeah.
This is an example of
This is an example of assigning a function to a variable. And then I can call the function by the variable name and I apply the same argument. Is it clear? Yes.
So how do you return a function from
Yeah, we will come to it. I have so many examples.
Is it good to write function inside a function inside a function?
That depends on how to optimize your code. Sometimes it's good, sometimes it's complex. Now, it depends on how you want to optimize your code. But of course, since it exists, it can help reducing the code size. But you know, it has pros and cons, basically, because sometimes when you keep reducing or using a lot of functional programming, sometimes the code becomes a little bit difficult to be understood by others. Okay? The fact of creating modules and reusing modules, that makes it easier. But you know, if the module, you don't need it so much or often, you can use the concept of functional programming just to reduce you don't define a function for one time and then use it in another function. So you can just call it immediately, okay? So functions as a first class object, they can take different forms. So they can act as arguments, function as arguments of other functions, and we already introduced this concept in the previous slides. And for example here, apply function. So I can put a function as an argument and apply to a value or apply to a list. And then we have square, okay, x multiplied by x. I can call apply function square over 5. So here, this illustrates that a function can be an argument of another function. Okay, and here it was applied on an int value. In the previous slide, we have applied to a list. So it's possible to apply it to different type of basic types in Python. Another usage of a function as first class object is that a function can return values or can return another function, return functions for other functions. Okay, so get multiplier here, it will return, this is the lambda expression, so it will return x multiplied by n. Okay, and now I can make an assignment. Doubler is a variable equal to get multiplier 2. What will be doubler here? What will be the type of doubler? It will be a function that will do the double, because here I don't return a value. Here I return lambda, it's an anonymous function. Okay, it's an anonymous function. So here, if I make doubler 5, it's going to call get multiplier, and get multiplier is going to call this function. So doubler here, if you see the type of doubler, it will return, it's a function. Okay, it's not a value. Okay, and look, multiplier of 2, so here is going to be 5 multiplied by 2. Okay, this is called doubler. If I want to create tripler function, what I will do, I will make get multiplier 3. And in this case, tripler will just multiply every number by 3. Yes?
So we basically need doubler, which is x. So we say that as x. So whenever we call doubler,
Yeah.
that means 5 is n.
So x is the variable, n is a parameter.
Yeah.
And n is used here to define a function with a particular parameter. Okay? That's the whole story. And another functionality of function as first class object is that we can use storing functions. So imagine you define a function, pure function add, and the pure function abstract. And then you can define operations as a list, equal, add, and subtract. So now, if you make operation 0, is going to call the function add. If you make operations 1, is going to call the function subtract. So here we can define a list of functions, and then you can call them by their indices. Yes, I can do the same also on dictionary. Okay, dictionary is one of the built-in functions. It's like a map, kind of. So it has a key and a value. And here I define operations. So the key multiply will refer to the function multiply, and the key divide will refer to the function divide. And in this case, I can do result equal operation by the key multiply. So I will call the function multiply, because here I specified this key. 10, 3, so it will return the output of the multiplication of the two numbers.
Doctor, so functions has return values. The previous one. case.
This one?
The previous.
Yeah, this one?
Yes. I didn't understand what's the use of lambda in this example.
Okay, lambda by definition, we're going to have lambda expression. By definition, it's an anonymous function. It's a function that doesn't have a name. So what is a function? A function, it's, let's say, a method that takes an input, return an output. So in lambda, this is the input, it's x, and the output is x multiplied by n. So this, we return what here? We return an anonymous function. Okay? This anonymous function, it has a parameter, which is n. Now, here, we define a function that does the doubling of every number. So I just call get multiplier, and I provide a multiplier of 2. And doubler now, if you provide x to doubler, in this case, is going to return the value. Now, get multiplier n, so if you pay get multiplier 2, it will return you always 2x. So 2x is not a value, it's a function. You see what I mean? Okay. Another concept also we need to understand, to be able to understand clearly lambda expression. You know, we can introduce lambda expression like last time, this is the expression, but I want you to understand the concept, how it works. So later on, when you see any lambda expression, you know how the function will be applied in reality. So usually lambda expressions or high order functions are applied on iterable objects. It means objects that we can iterate over. It's like what you have seen in Java, iterators. Okay, we have arrays, array list. All of that are as part of iterators, iterable. We can do iteration, we can use for loop. So what is an iterable? It's a Python object that is capable of returning one of its member at a time. A table is an iterable. Okay, you can return any element of the table, permitting to be iterated over a loop. You can use a for loop, you can use a while loop. Okay, if you are able to apply this on an object, we say that this object is iterable. Okay, we can do iterations over it. Okay, and yeah, I will show you how it is implemented in Python. Okay, it uses an iterator inside. It's like you apply, you have forward iterator and backward iterator in Java. So basically, it's the same thing. So how iterable works? So basically, in every object, an iterable object, it has to define the iter function. So the iter function, this defines that this is an iterable. Okay, and this will allow to later on apply a for loop. So for example, a list is an iterable, a dictionary also is an iterable. I can go over all the keys of a particular dictionary. And also, it has a function next, because as you already seen in Java, when you use an iterator, we can go dot next. Okay, and you have used has next to check whether you have reached the end. You know, this is the concept of any data structure. It's independent from Python, is independent from Java or a C language. All of them, they share the same concept when we built in this data structure. So this is a data structure, okay, which are iterable. They define the iter function and they define the next function if we want to go to the next element. And we can do iterations. So the general rule is for each element in iterable. If you have an iterable object, you make for element in iterable, and then you can go over this iterable. But you need to differentiate between an iterator and an iterable. So an iterable is an object that can return an iterator. Okay, so an iterator allows you to go through all the elements of that object. So now if I have an iterable here, I can define a list. So a list is an iterable object in Python. Okay, we define this object, and this object, it has iterators. So what the iterator will do? It will define the next function to go from one element to another.
Like a guide,
Huh?
like a guide.
Yes, it's like you have seen in data structure. You have taken collections in Java, and also in data structure, you make pointers to jump from one element to another. So basically, they are pointers that allows you to jump from one element to another. But the for loop is like it's going to be a wrapper layer on top of the iterator to go through all these elements inherently. Okay. So a list, this is an illustration. A list is an iterable. It defines elements, and you can iterate over these elements. And so if you call the iter function, is going to call the iterator at the first position. Okay? Just remember collections in Java. We do the same thing. And then we call dot next. When you use a for loop, is going to call the dot next in order to move from one element to another. This is the concept of iterable. It applies to arrays, it applies to list, it applies to dictionary, it applies to different type of data structures. Okay, so this is an example of a custom iterable. You can build your custom iterable. If you want to define a class that is iterable, you need to implement the method iter. Okay, so we have the constructor in Python. This is the object-oriented, this is the constructor in Python. It has the method init. Self is similar to the keyword this in Python. It refers to the object of the same class. And these are the parameters to initialize the count. For example, I want to make a count that goes from the lowest value to the highest value, from 1 to 5, for example. Okay, so I can define the lowest value as 1, the highest value as 5. Here we define, this is an iterator, and we define the next method to tell how to go from one element to another. So here is going to jump from the current value until it reaches the highest value. If it reaches the highest value, it's going to throw an exception, stop iteration. So this will raise to Python that we have reached the end of the iterable. Okay? Else, if I didn't reach the end, I'm going to increment the current position by 1. So it will go from this position to this position. This is an example of usage. Now, if I define this class as an iterable, I can create an instance of this class. I want to create a counter between 1 and 5. And then, since this is an iterable, I can use a for loop to go through all this number of the counter. So if I just call print processing number, you will see it will go from 1, 2, 3, 4, 5. When it reaches to 5, it will raise this exception, and this will let the iterable object that it has reached the end of the iterations. Okay? So let me give you another example. The example range. So this is like count, but in range I can define the steps. I want to jump, for example, one element. So I can define a step of 2. I can jump 2 elements. I can define a step of 3. So same thing, we define a constructor. We have a start element, a stop element, and we have a step element. And we define the same thing, the iteration function. And we define the next function to tell how we're going to jump. So we're going to jump from start to stop, and of course we make sure, so every jump we're going to add a step.
Which is 1.
Yes. So now if I apply this one for number in range 1 to 10 and step to 2, it's going to return 1, the first element, then 3, then 5, then 7, then 9, and then it stops when reaching 10. And now look here, it only returned the odd numbers because I have jumped one element, because the step here was defined equal to 2. Okay. So the most important thing now, the takeaway here is that every iterable, it defines an iterator method and defines the next method. And this is something very similar to what you have seen in Java collection framework, and also in data structure. I'm sure they have worked with Python, or with pointers, okay, in order to define lists, linked lists, for example, or these type of data structures. Okay, linked list, for example, you can go back and forth. You have next and backward also, previous, yes. So all of this is just an introduction to the concept of functional programming that we have started in the very beginning. And I want to introduce you to, so now going back to the definition, it's a style where functions are the main building block, okay? And we want to have the data being immutable. So we have introduced the first class functions, the high order functions, and the pure function. And this now will allow us to introduce more easily the concept of lambda expressions. So lambda expression is one of the forms of functional programming, okay? And they are defined as anonymous function created with the lambda keyword. So if you want to create an anonymous function, you start with the keyword lambda, you provide your arguments, this is what you put between parentheses in a pure function, and then you define the expression that will transform the output. And this is a very powerful tool as I'm going to show you. Now, this is an example. This is a regular function that makes the sum of two numbers, and they can define an anonymous function that is called add lambda equal lambda AB, these are the arguments, and will return A plus B, which is the transformation that we will do on the data. Okay, then we'll print add lambda 3, 5, so this is going to return 8. And this is possible because functions are first class objects as we already introduced, and the benefit of lambda expression and functional programming, these functions are quick, you can quickly create them, and disposable. They will not stay in the memory. They will be executed and that just disappear, because when you create a function like this, it's going to stay in the memory. When you create it like this, it will disappear from the memory after it is executed. Okay? So now, perfect for short-lived functions and that are not needed after their immediate use, which reduce the need for formal function definitions. These kind of optimizations are really very important when you work in data science. You know, in data science, every single operation counts because you will be dealing with a huge amount of data. If you don't optimize your code, okay, you will, even if your code from functional perspective is correct, it's not going to be efficient from performance perspective. So this is really important to know when to use these tricks. Yes?
I was actually going to ask, why do we need that?
Yeah. It's basically mostly performance-wise. And I'm going to show you the performance in terms of memory in some of the functions later on. Okay? So this is what you need to, this is the syntax, this is the general syntax. Now it must be familiar for you. First we provide the arguments and then the expression. And the good thing is that this type of anonymous function or lambda expression, we can use them with built-in functions and function programming tools like map, filter, sorted, and reduce, as I'm going to introduce later. Okay. So this is so lambda expression are example of anonymous functions. This is another example here where you want to use sorted. So in Java you already worked with comparable and comparator. In comparator you need to define what is the comparison criteria. Remember about this. So sorted, it's not a class, it's a function, but it's a function that will take a criteria to sort this data. For example, imagine that you have a data like this, which is a list of tuples. And every tuple, it has an ID and a string that represent the name of the item. And now, if you would like to sort this data based on the items, look, 1, 3, 2. I want to organize them 1, 2, 3. So here, we can use lambda expression by applying sorted on data. And the key here, it means the sorting criteria will be the first element of the list. Okay, now this is the second element of the list. X1, it means I would like to sort based on the string. Okay, on the name, yeah. Now, if I want to sort them with respect to the ID, I will put X0. Okay, look now, this is an example of using functional programming with lambda expression, okay, as an input to a function data. So this data, it takes, or this function, it takes a variable of type list as an input, and also it takes a variable of type function. So here, function, it's as an argument for that function. Okay, and this is the equivalent if we don't do lambda expression. So you can define a function get fruit name, which return the first element of the tuple, and then sorted will be applied to get fruit name. So this code is equivalent to this one. Okay, you can see it in the slide. So I always, when I use lambda expression, I provide you the equivalent without using lambda expression, so you can understand how it is used. So maybe in the beginning it may look weird, but you know, as you use it, you'll get familiar with that expression. This is another example. Look now. Now I would like to sort these names, okay, according not to the alphabetical order, but I want to sort them according to the length, to their length. You can define a function that will return the length of each element and then apply it, but here you can use names.sort because a list has a sort method, and here you need just to provide the key as lambda expression and provide you the criteria, which is the length of each name in the list. Okay, so it has several usages that I'm going to introduce in this in the following slides. So another important aspect is that lambda expression can be used as a closure. So what does it mean, a closure? Let me just introduce closure. A closure is a function object that retains access to the variable coming from the outside. So look now, we have an outer function, and this message is defined, this variable is defined as a variable of this outer function. And then I define a function inside the function. This is possible. It's not only in Python, but in other programming languages. And then I make print message. So what is this message? It's like it's going to the global variable because it is outside of this scope. Okay? So when a variable is defined outside of the scope of a function, so we call it like a global variable with respect to its current scope. This is what we call closure. And we can define lambda expression as a closure as well. Look now, calculate power, lambda x. So this is the local variable. This is the argument. But I'm going to make x exponential the power. Power here is not defined in this scope, is defined in the outer scope. Okay, so this is equivalent. Now, if you want to do it without lambda expression, you can define a method that is called multiplier, and then define triple, and triple you can call triple 10. So 10 here is what? Is x. Okay, and 3 here. Now 3 is outside of the scope of the lambda expression. Yeah, now the closure is with respect to the n, to the exponent, because n is not defined in the scope of the lambda expression. It is defined in the scope of the function. Okay, I'm going to stop here, and tomorrow I'm going to introduce you how to use lambda expression with functional programming tools like map, filter, reduce, and also others.